Welcome to this electrical engineering knowledge sharing channel. We are discussing battery sizing calculation for UPS system. We have already completed one video number 79 for this battery sizing calculation, and that has been done for the constant load or constant battery current discharge. Now, in this video 79, we said that for variable current or variable load, battery sizing calculation will be done, and one next video, that is our video number 80. Now today we are discussing that. Now in this discussion we have considered the battery need to discharge the current on the variable load, means the load is not constant, load is changing with the time. How the load means load current. So load current changing time means battery need to supply the changing current. That is because the battery we have already shown before how the battery is getting discharged. We have the converter and then we have a inverter. This is a inverter and this is our converter, and battery is connected over here, and this is a load is connected, AC load is connected over here. The moment the AC load getting changed, increased or decreased, automatically the inverter, this inverter has to cater that amount of current. The inverter is getting what? DC input current. Now DC input current normally coming from the converter, but the power supply is not available, so converter is not working, so battery has to discharge. As the load need the current, when the load is more, you need more input current. When the load is less, it needs a less input current. That means the battery is discharging it not at a constant current. It is discharging at the variable current, and that variable current depends on the load, and load is sequentially changed or unsequentially changed. So this changing load, how that and battery is getting discharged with a variable current. So with that variable current, how to do the battery sizing, that is we are discussing in this video. So to demonstrate or to reduce the video time, I have most of the information I have already put on the board so that our video time can be reduced. So first, when we are going to calculate the battery sizing for this type of variable current, first we have to go to the field and we have to collect the current data from the field, how the UPS output load is getting varied over the time. And suppose the UPS need to back up or the battery need to back up for 3 hours, then over these 3 hours, how the load current is getting varied. So based on the load current, we have to calculate the corresponding DC current, and that DC current, as the load current is variable with the time, so automatically inverter DC current also will getting varied, and when the DC input current to the inverter get varied, and that current we have to plot on the picture on the time current characteristics. That is, we have put over here this side x-axis, along the x-axis we have put the discharge time, and along the y-axis we have put the discharge current. As we have said that this this battery need to back up for 3 hours. So over the 3 hours, how the load current is getting very varied, that is we have shown. So from the picture you can see first 1 hour, the current is only 5 ampere for 1 hour. After 1 hour, the current is getting increased from 5 ampere to 35 ampere. This point is a 35 ampere, is increased to 35 ampere, and that is maintained for 30 minutes. After 30 minutes, suddenly the current get dropped to 15 ampere. This point is a 15 ampere point. The current dropped to 15 ampere. That means the variation is negative. From here 5 ampere it increased, positive variation. Now from 35 ampere it suddenly dropped to 15 ampere. There is a negative variation. Then that 15 ampere current is maintained for another 75 minutes. After 75 minutes, this 15 ampere current suddenly increased to 45 ampere current, okay, and then the period is getting over. So this is the load profile. If you draw the profile of the current drawn by the battery, given by the battery, so this below hatch mark portion is actually the area or the current profile of this, okay. Now to calculate the ampere hour of this current, now the current is not constant. We have seen before in the previous video, we have discussed that when the battery, suppose a rated battery is going to discharge for different time, then automatically it cannot deliver the entire ampere hour, or then the automatically ampere hour will be reduced. So to calculate the reduced ampere hour, we use one factor that is called the rate of discharge factor. We have calculated for the constant current in terms of ampere hour, but we can calculate that factor in terms of ampere hour, as well as we can calculate that factor in terms of current also. So IEEE has fully, IEEE 485 is completely follow the current principle. So that, as we have already discussed how to calculate for the ampere hour in terms of ampere hour, today we will discuss the alternative one, how to calculate in terms of current. So as the current, as a particular, suppose a battery is a rating for C8 battery is same 104 ampere hour capacity. This battery, suppose if we have a battery C8 rating battery 104 ampere hour, which can give, that means it is a 8 hour rated. We have already discussed this part. The C8 means this battery is rated for discharge, is rated discharge hour is 8 hours, and in 8 hour it can give 104 ampere hour. That means it can give current of 13 ampere. So if the battery get discharged over 8 hours, then it can give a 13 ampere constant current. That is, we have discussed in the like this way, and it can discharge up to 8 hours. Now if the same battery is getting discharged over, suppose it is a discharge over 4 hours, then it cannot give 13 ampere, it cannot give 104 ampere hour. It will, capacity of the battery will be reduced, because for 4 hours, if I take the entire, if I want to discharge the battery fully in 4 hours, then instead of 13 ampere, it will give higher current, 22 ampere. But ampere hour, how much? This into 4 means it will get only 88 ampere hour. That means, you see, there is a reduction of the ampere hour. This factor we calculated for the constant current, we calculated in terms of ampere hour. But as this is a variable current, so IEEE has recommended to calculate in terms of current. This factor, this rate of discharge factor Kr, is to be calculated. For the constant current is only one time. But here, as the current for each instant are different, for each area, the K factor will be different. So for each area, we have to calculate the K factor. That is the first job to calculate the ampere hour of the battery when the current is not constant. Okay. So how we will calculate that current? For that reason, as per IEEE recommendation, entire area, we have to first find out couple of things. So for each current, how much duration, that is we have to find out. First current, how much? That is a 5 ampere. Okay. That is for how many hours? That is a 60 minutes or 1 hour, you can say, right? Then the next current is how much? 30, that is a 45 ampere, right? 45 ampere, it is for how many minutes? It is for 30 minutes, right? Then the third current is a 20 ampere, right? 20, it is a 15 ampere, not 20 ampere. It is a 15 ampere. It is a 15 ampere. It is how many minutes? It is a, sorry, it is a 45, no, it is 35 ampere, no, it is 35 ampere. This is a 35 ampere for 30 minutes. Then next current is a 15 ampere. 15 ampere, how many minutes? 75 minutes. And next current is a 45 ampere. That is equal to 15 minutes. That is about the current delivered by the battery. So first, from this figure, we have to make a section. You say this is a first, if you say this time is a P1, so first P1 is 61, this is our P2, this is our P3, this is our P4. There are 4 sections. So first section is, this is a first section, we can say A1 from here to here. Then this portion, from this portion we can say A2. And next portion, this is, we call say A3. And this portion, last portion, we can say A4. Okay, you can say this way. This from the first instant to first current, we can say it is a area P1. It is a section area A1. Second portion is a from here to end of the second, that is A2. Then the third one is from the start to the end of third, that is A3. And fourth one from the start point, battery discharge starting after the end of last period, that is A4. So what we have to do, for each area, we have to calculate the K factor. So how I will calculate the K factor? That is, as per IEEE, for this, suppose for the 5 minute, if I want to calculate the K factor, that this battery is a, what is this battery? This battery C8 rating is 104 ampere, and the corresponding current is how much? That is, a current is a 13 ampere. This is ampere hour and this is a ampere. Now, for this 5 ampere current, when it is discharging at the rate of 1 hour, for that what will be the K factor? As per IEEE, the battery rated ampere hour divided by the battery rated ampere hour divided by the discharge current characteristics of the battery for 1 hour. That means this C8 battery, when it discharges for 1 hour only, the entire capacity to be discharged by 1 hour, then how much current it can give? So that C8 capacity divided by that current, suppose this current is A and the time is T. T means here is a T is 1 hour. In 1 hour, if this C8 battery get discharged, then how much current it can give? That we have drawn the picture over here. You see, this is the C8 battery. This detail we have already discussed in the other video. This is the discharge characteristics of the battery whose rating is a C8. C8 battery, if it discharges over 8 hours, then it will give 13 ampere, it will give ampere hour 104. If the same battery is discharged is 1 hour, then what will happen? It will give 58 ampere current and it will give 58 ampere hour. So what I have to do, this rated capacity, if I want to know the discharge factor KT or KR discharge factor for 1 hour, suppose 1 hour, first one, then how I will calculate? I will take the rated capacity, I will divide the rated capacity by 1 hour discharge. 1 hour discharge, how much 1 hour discharge? 1 hour discharge is your 58 ampere. So this is equal to 104 by 58 ampere. Okay, it is the ampere hour and this is the ampere. So that is a first K1 factor for this portion. Okay. Similar this way, for each time we have to calculate the K factor. Now, second part of that, once we calculate the K factor, then we have to decide what will be the ampere hour. The ampere hour will be simple. This ampere, what is that ampere will be the change ampere. That means when we will be calculating the ampere hour for this 1 hour, how we will calculate this? That ampere hour equal to, for 1 hour, whatever the K factor, that K factor multiplied by the corresponding current, change of current. Suppose this current is 5 ampere. So 5 into K factor, how much? 104 by 58. That will be the ampere hour for this 1 hour. So this way we have to calculate the ampere hour for each. But this current is not the only this current. This current is the change of current from the previous value to new value. Here we don't have any previous current is 0. That's why change is 5 minus 0 means 0. That's why 5 ampere. But when we are going to the second part, then here's the interesting part over here. You see here, the current is for 35 ampere, right? But 35 ampere, when this battery is going to 35 ampere, it was already delivering 5 ampere current, right? So how much additional current is coming? 30 ampere. So that differential current we have to calculate when we are going for the variable load. So in the second part, our current will be, total current is 45 ampere, but 35 ampere. But when it is delivering 35 ampere, at that time, what is the battery condition? Battery was already supplying 5 ampere current. So how much additional current it is supplying? 35 minus 5 is 30 ampere. So we have to calculate this 30 ampere. When we are going to calculate the ampere hour, we have to calculate the ampere hour in terms of 30 ampere. Okay. And when we calculate for this current, when we calculate the K factor, how we will calculate the K factor? K factor will be calculating in terms of 30 minutes. Okay. And that is the second part. Similarly, when we go to this part, how I will calculate the current at that point? What is the current? Current is 15 ampere, right? What is the previous current? Previous current was 35 ampere. So what is the current is coming? Minus 20 ampere. So this 20 ampere current will be multiplied by the corresponding K factor to get the ampere hour. So when we will be getting the new ampere hour for each area, how I will calculate? Change of current multiplied by corresponding K factor for that time. For that interval. So when we are calculating the time for K factor for this, how I'll calculate? We need to calculate it for that time, for that duration, that we are coming back afterwards. So about the current part, you can understand when we will be going the variable our ampere hour capacity for each area. For each area, we need to calculate the first the change of current, and that change of current will be multiplying by corresponding K factor. Then we will get the total ampere hour. Now that means we have to calculate this thing. How we will do this thing? We will show this thing now. So I have a fourth section over here. First section is A1. A1 section, how much current? Current is 5 ampere, right? And corresponding time is how much? Corresponding time is 1 hour, right? This is a current C. Time is, or P you can say, P is a 1 hour, okay? And previously there is no timing. So our change of current, how much? Change of current is only 5 ampere, okay? And this is one part. And we'll put here total time. Here I will put a total time, okay? Now the second part, when I going to A2, A2 is how much? A2 is your current is a 35 ampere. How much time? That is a 30 minute, right? How much change of current? 30 ampere. Now this time, total time, this is another total definition of total time. What is the total time? The total time is from the start to end. From total time, not the start to end. Total time is the where a particular section we are considering, from that point to the end of the discharge. That means if I consider total time for section A1, okay, this section is A1, this section is A1. For this section, what is this T stand for? T is a total. Huh? This is a T total. What is this T total? T total is from the start of this section up to end of the discharge. Up to the end of the discharge means up to this point. That is the time for this section. This portion section time, this section is suppose A1. This is A1 section. A1 section time, what is this T? Though it is discharged for 1 hour only, but we need to consider this T is the total time of this, because the battery is giving this current totally over the entire period. So from the start of this point up to the end of the battery discharge. So that means 3 hours. So this will be 180 minutes this time. Okay. Second, this is for A1, not this one. Okay. This is, we can say A1. This A1 is a 180 for the A1. Huh? This 180, this is a 180 minute. Now when you go to the second one is this is a change current, right? This change current, second section start from here, okay? So second section T total how much? From the start of the time to the end of discharge. So this is how much? This will be 120 minutes or 2 hours, right? This total. For A3 section, it starts from where? It starts from A3 section starts from here, right? Where it has gone? It has gone up to the end. How much time this is? This is a total 90 minutes. So A3, what is the current? A3 current is your 15 ampere, right? 15 ampere. How many minutes? 75 minutes is getting discharged. How much current change? This change is your 30 minus 15 minus 20 is the change of current. And how many minutes? Start of the third section up to the end. So how much it is? It is a 90 minute. This way I have to calculate the T total. Then for A4 section starts from here, right? So A4 section current how much? 45 ampere. So how many minutes it is? It is a 15 minute. How is the change of current? Before starting of the fourth section, what is the current was? 15 ampere. Now the current increased to 45. So how much change of current? Change of current is a 30 ampere, right? 45 minus 15. So 30 ampere is the change of current. And what is the T total? T total starts from this section to the end of discharge. So that is only 15 minutes. Okay. So this way we have to calculate the change of current. Why we are doing this thing? You try to understand, because if I calculate only this area, that will not give the figure, because the battery is already loaded 5 ampere. over that we are putting differential load. So for that differential load, we need to calculate how battery will be discharging. That's why the differential load for each section we have to calculate. How we will calculate that particular section is starting, what is the current of that maximum current of that section minus previous current. So first current is 5 ampere, previously no current was there, so change of current 5 and total current also 5. For the second section, current is already 5 ampere was there. Now the battery has to discharge 35 ampere. So additional how much? 30 ampere additional current battery has to discharge. For the third section, battery discharged to 15 ampere, but already it was discharging how much? It was discharging 35 ampere, right? So how much additional he is supplying? 35 minus 15 minus 20 ampere, it is negative discharge. The impact of the battery will be encountered by this minus. Then the fourth section, it was delivering 15 ampere, suddenly it increased to 45 ampere. So it is a additional current is supplying, change of current 30 ampere. Now this 30 ampere additional current, how many minutes? From the start to end, 15 minutes. For this section, start to end, this 90 minutes. So these were the total time to be calculated. Now the K factor for each section, now we have to calculate based on this timing, not the individual timing. Based on that timing, we have to calculate the K factor for each section. Okay. So A1 section means first section, K factor to be decided for 180 minutes means 3 hours. So we have to see for suppose K R discharge factor KR A1, if I say KR A1 how much? We have already said rated ampere hour of the battery, that means C8 capacity of the battery divided by this A1 section, what is the total time? For that total time, what is the current it can discharge? So if you see this 180 minutes means 3 hours. Now if you go to the battery characteristics for 3 hours, how much current it can deliver? You see here 4 hours it can deliver 22 ampere. For 2 hours it is 37 ampere. So 3 hours it will be in between, that is a 29.5 ampere I have calculated. So it is a 29.5 ampere this current, and this is ampere hour. So this will give you the factor KR1. That factor how much it is coming? It is coming 3.52. Okay. Similarly KRA2 for this section, if I calculate the K factor, it is 104 divided by, for second section how much time? 120 minutes, right? A2 section time is 120 minutes. 120 minutes, how much current it can give? It can give 37 ampere. So how much it will be divided by 37? It is giving 2.81. So if you go K of A3, what is the factor? That is same 104 ampere hour divided by A3. What is the time? 90 minutes, means 1.5 hours. Now the 2 hours is a 37 ampere, 1 hour is 58 ampere. Okay. So in between if you calculate, it is giving 47.5 ampere. So it is a 47.5 ampere, corresponding factor how much? 2.18. Okay. Similarly, if you calculate KRA4, how much? That is 104 is the rated capacity of the battery, and 4 hour, this particular battery, if you discharge how much minutes? 15 minutes. If you discharge in 15 minutes, it is giving 133 ampere. So we divided 133, this will give a 0.078. So these are the factor for this fourth section. Okay. Now that factor I have noted down over here. You can see 3.52, 2.81, 2.18, 0.78. Okay. Now how to calculate the ampere hour? Now what we have to do? We have to calculate the ampere hour for each subsection. So A1, that subsection ampere hour how much? We have already said ampere hour is how much current it is giving? 5 ampere, right? 5 ampere into K factor. K factor is how much? K factor is a 3.52. If you multiply this, you will get A1 equal to 17.62 ampere hour. That is will be your this figure. Similarly, A2, for the A2 how many? A2 we have said what is the change of current. So change of current how much? It is a 35 minus 30 ampere current into K factor how much? 2.81. So that will give how much? We'll calculate. A3 equal to how much? A3 is a change of current. So A3 is this section is A3, right? Before that how much current? I have a current of 35 ampere and this current is 15 ampere. So change is how much? 15 minus 35. So it is a minus 20. This into how much? Into time how much? This will be K factor how much for this? It is a 75 minutes. 75 minutes K factor means how much it is K factor? 2.18. There is a K factor for, we have already calculated. Now the A4 is how much change of current? It is a 45 ampere, right? Minus 15 ampere. So 30 ampere. 30 is a 45 minus 15. That equal to 30 ampere into K factor how much? 0.78. These are the 4 area we are getting. On a 4 area means 4 ampere hour. So this equal to how much? This will give, A2 will give your 84.3 ampere hour. 84.3 ampere hour this. And the third one, if you go the A3, if you multiply this, you will get how much? This will give you, A3 will give you minus 43.6. Okay? Because it is minus sign. You have to keep in mind. Okay? And if you see these are 45 minus 30 into this is 7, 8. If you multiply this, you will get A4 section equal to 23.4 ampere hour. Okay? So now what will be the total ampere hour? A equal to sum of A1 plus A2 plus A3 plus A4. Okay? That is the total ampere hour. If you sum up this thing, how much you will get? You will get 81.72. This is the total ampere hour is coming out of this calculation. So this amount of ampere hour I need from the battery as per this duty cycle. Now this is the uncorrected capacity. We are considering this battery is operating at the ambient temperature. Okay, at the ambient temperature of 10 degrees centigrade in the cold country. Okay, that is the first consideration. Second consideration, we are thinking this battery will be getting discharged up to 1.8 volt. After that, we will not allow to discharge the battery because the capacity 104 ampere hour which we are telling, this capacity is when the battery is getting discharged over 8 hours and battery voltage will be 0 after discharge. But here we are considering the battery will not allow up to the 0 voltage. It will discharge up to 1. This is the latest. We have to refer the our video number 79 when we have discussed all this point. Normally a standard battery, the capacity which is mentioned for 8 hours, that is we have to consider at the end voltage of this battery 0 volt. But we cannot discharge the battery to 0 volt because if the batteries get to discharge 0 volt, then what will happen? Inverter input voltage 0. Then inverter will not work. So we do not allow to discharge the battery fully. We discharge the battery up to that point when the voltage will be maintained up to our requirement. So if the battery nominal voltage we have already discussed in the previous section, battery nominal voltage is 2 volt. So if the battery drop down from the nominal voltage to 5 to 10%, 10% means how much? It is 1.8 volt. After that, we don't allow the battery to be discharged. Now what will happen when we are limiting the battery discharge at 1.8 volt, then it will not able to deliver its entire capacity. So at this voltage, how much ampere hour it can deliver? That is, we have to discuss with the battery manufacturer. And normally, most of the manufacturers, they recommend their battery will be, if the battery discharge is limited to 1.8 volt, means 90% of the rated nominal voltage, the battery will be able to deliver only 80% of its capacity. Balance 20% capacity, it will not deliver. If you look the battery discharge characteristics, discharge over the time, you can see battery discharge characteristics like this. That means at this point it write down to 90% voltage. Yeah, it is a voltage this side and this side ampere hour. It will deliver this ampere hour and then it will drop at this point. This is your 90% of the voltage, this point, and at this point it will deliver 80% of its capacity. This side is the capacity, ampere hour. 80% of the capacity it will deliver. After that it cannot deliver. Rest of the power it cannot deliver. It will deliver up to this amount of power. Its total power is like this. So that means that 20% delivery which he cannot do, that I have to consider in the discharge factor. That's why we said that discharge factor KD is another factor that is equal to 1.2 because 80%, 20% margin I have to keep for the discharge. So that is KD. So this is one factor. Rate of discharge we have calculated. We have considered rate of discharge factor in this calculation. And KD factor we are considering over here. Okay. Now the third point is the temperature. As we mentioned, this battery is operating at 10 degrees centigrade. You know the battery, we have already discussed all this point in video 79, that battery is rated at 25 degrees centigrade. At this temperature it will give its rated capacity, but if the temperature goes down, then battery capacity drop down because chemical reaction take place slowly, so it will produce less current. So how the temperature, with the temperature, how the capacity gets changed, that we have shown. If I consider operating temperature 10 degree, the factor is 1.19. So there is another factor, KT, temperature factor, that is a 1.19. Then we need to consider another factor, that is we call the aging factor. What is that? The battery capacity, due to various reasons of the discharge, ambient condition, installation condition, using condition, the battery gradually reduces discharge capacity. Whatever the rated capacity, it cannot deliver. So that's why every plant, they do the battery capacity test every 6 months, and they noted how much capacity they have. That's why the 20% capacity margin we need to consider, considering the reduction of the discharge capacity. So the discharge capacity, there is another factor, aging. Due to the aging, battery got reduced its capacity, and that 20% additional margin we keep considering that capacity reduction due to aging. That factor K aging, that equal to 1.2, because 20% margin I have to keep for the aging. And the last point, another factor we have, that we have already discussed, that is your safety margin, that is just SPR capacity in the battery. Because today I am calculating the battery based on that load profile. Tomorrow I may have adding some additional load, and that load, then the battery will not able to cater it. So that additional load, generally we consider 15% or 20% additional load. If I consider 15% SPR capacity in the battery to cater for the additional future growth of the plant, then that factor will be 1.15. That is your SPR capacity factor. So once I get this capacity, this is uncorrected capacity based on the battery present characteristics. But when we apply on the various factors, that four factors, then that will be the corrected capacity of the battery which we need. That equal to kato? That equal to this ampere hour into first is your discharge factor, due to the not to able to discharge battery fully up to 1.8 volt we discharge. That's why the factor is coming 1.2. Then the battery is operating at 10 degrees centigrade. There is a factor 1.19. Then we have a factor of aging factor, that is 1.2, and finally we have SPR capacity of 1.15. These are the factors we need to consider. If we consider this thing, then 81.72 ampere hour, 72, this into, if we calculate this factor, it 1.2 into 1.19 into 1.2 into 1.15, then it will give you capacity 161 ampere hour. That is the capacity we will get. That is the corrected capacity of the battery for this particular load profile. If we need this battery, we need a 161 ampere hour battery capacity. Now our battery is, what is the capacity? 104 ampere hour. So this 161 ampere hour battery, then how many battery I need? How many battery bank? That is a number of battery bank required, that equal to this 161 divided by one bank capacity 104, that is coming approximately 5. So we need actually 1. It is coming 1.54. So that means we cannot do the fraction. So we have to consider 2 battery bank. Okay, 2 bank we have to consider. Okay, so how will be the connection? The connection will be 2 bank will be connected. How? It will be connected in parallel, because each bank will give half of this capacity. So this is the battery. This is suppose one bank, and then there will be another bank like this. These are the multiple batteries. This connected over here. These two will be connected in parallel. Then it will go to load. Okay. This will be giving 50%. 2 bank we are considering. Each bank is giving how much? 104 ampere hour. 104 ampere hour. Okay. And I need 161. From this I will get it. Now, how many cells will be here in each bank? That is, I have to calculate based on the voltage requirement of the inverter. This inverter, we have seen that battery is connected. How the battery is connected? Like this to the inverter. Now this inverter, how it is designed, or the rectifier output voltage, how the rectifier output voltage or inverter input voltage is decided. If this voltage is decided by 24 volt, then I have to consider how many cells I need at this point, 24 volt. That means each volt is a nominal voltage we have considered is lead acid battery. It is a 2 volt, right? 2 volt. But if we go to the nickel cadmium battery, then it will be 1.2 volt for the nickel cadmium. But for the lead acid, it is a 2 volt. Now 2 volt, if I want to get 24 volt, how many battery to be connected in series? 24 divided by 2, that is your 12 cell. But in the case of nickel cadmium, it will be different figure. So that 12 cell to be connected in series like this way. 12 cells, and it will be connected in series, then the voltage will be 24 volts. So here how many cells I have? I have 12 cells. And how many bank? 2 bank. Each bank has a 12 cells with lead acid battery which is giving 24 volt. So my system is 24 volt battery I am required. How much ampere hour? We need 161 ampere hour. So as we have considered this 104 ampere hour batteries, we need a 2 bank of battery. That is our battery sizing. So this way I need to calculate the battery sizing for the variable load. So when we are going to calculate in a summary what we have seen, first we have to consider, we have to collect all the data for the variable current or variable load from the field. From there I have to calculate the, for each variable section or each section, how each time or duration, what is the variable load, that current to be calculated in terms of DC current. How to calculate DC current we have already discussed in the video 79. Please refer that. From that current we have to plot the curve, variable current curve, current versus time curve. From the curve, for each section we have to calculate the change of current. Once we do the change of current, and then we have to calculate each section starting from the start of this section up to the end of the battery discharge. What is the duration? That duration you have to calculate for each section. Keep in mind, I am repeating this thing because you should not make mistake over here. To decide the total time for that particular section in deciding K factor, from each section start to the end of the discharge, end of the battery discharge, total duration, you have to calculate that timing. So based on that timing, you have to see what is the discharge current for the battery for that particular time. If the total time suppose 2 hours, then corresponding that particular battery which we are considering nominal capacity, for that particular hour, what is the discharge current? That current of that nominal capacity of the battery, C8 capacity or C10 capacity, that will be divided by that particular current, that will give you K factor for that particular current for that section. Then that K factor will be divided by the change of current. That change of current into K factor will give the first area or ampere hour required for that particular current, for that particular change current. In this way, each area ampere hour to be calculated. Then you have to sum up all these area. That means if the current P is the time, then AP minus AP minus 1, that P equals to 1 to whatever is decided. So this into multiplied by K factor, that will give you the ampere hour capacity of that particular section. Then if you sum up that area, that will give the total capacity. Okay. Without summation AP minus into K factor, AP minus AP minus particular time and the previous time, whatever the current change, that current change into K factor will give the area of that. In this way, if you sum up all the area, that area will give you the total ampere hour capacity. Then this total ampere hour capacity to be upgraded, it is uncorrected capacity. How will you upgrade it? Will be upgraded by applying the discharge factor, which we explained. Then we have to apply the temperature factor. Then we have to apply the aging factor. Then we have to consider, you have to apply the spare capacity margin. Then we will give the total capacity, ampere hour capacity of the battery. Then from that, we have to calculate the how many battery banks is required, that each battery bank how much ampere hour it can give. That ampere hour, the total ampere hour requirement divided by that ampere hour will give the number of banks. And then each bank how much voltage, that depend on the inverter input voltage. If the inverter input voltage is 120 volt, then how many battery will be required? 120 divided by 2, and 60 cells are required. That means in this way I have to connect 60 cells, and then that type of 2 banks to be connected to get the required ampere hour. These are the way we have to do the battery sizing calculation for variable load. So I am closing this chapter over here, and if you have any queries, please throw your comment. I'll try to respond. Next video we will go in the slightly in detail of the circuit diagram of this rectifier and the inverter, and we'll try to use how this will work out. All these things we'll discuss in the next video. And thank you very much for your partnership. Thank you.